Good morning, my dear students. In this particular video presentation, again, we'll discuss some more problems meant for competitive examinations or JEE. The first problem meant for today, it goes like this. If sine theta plus sine square theta plus sine cube theta is equal to 1, prove that cos power 6 theta minus 4 cos power theta plus 8 cos square theta is equal to 4. Let me just think about the answer. It's not at all a difficult task. It's a very simple result. Just see here. Sine theta plus sine square theta plus sine cube theta is equal to 1, which implies sine theta plus sine cube theta is equal to 1 minus sine square theta, which implies sine theta into 1 plus sine square theta is equal to cos square theta. Let me take square on both sides. Sine square theta into 1 plus sine square theta the whole square is equal to cos power 4 theta. I'll try to bring everything in terms of cosine because my result is in terms of cosine alone. Now for this is 1 minus cos square theta into 1 plus 1 minus cos square theta the whole square is equal to cos power 4 theta, which will imply you 1 minus cos square theta into 2 minus cos square theta the whole square is equal to cos power 4 theta, which will imply you 1 minus cos square theta into, let me use formula of a minus b whole square. This will be 4 minus 4 cos square theta plus cos power 4 theta is equal to cos power 4 theta. Let me just multiply fully. I mean to say 4 minus 4 cos square theta plus cos power 4 theta minus 4 cos square theta plus 4 cos power 4 theta minus cos power 6 theta. Minus cos power 6 theta minus cos power 6 theta. I rubbed off this, minus cos power 6 theta minus cos power 4 theta is equal to 0, implies 4 minus cos power 6 theta. Then let me group all cos power 4. I end up with plus 4 power cos theta. Then cos square theta I will group. I end up with minus 8 cos square theta is equal to 0, which will imply you cos power 6 theta minus 4 cos power 4 theta plus 8 cos square theta is equal to 4. That is what I am supposed to prove. It's a very simple result. It's not at all difficult. Just see here. Sorry, I'm not well. Just bear with me if I cough in the middle. Sin theta plus sin square theta plus sin square theta is 1. Sin theta plus sin cube theta is 1 minus sin square theta. Sin theta and 1 plus sin square theta is cos square theta. Sin square theta and 1 plus sin square theta whole square is cos power 4 theta. I am taking square on both sides. I am trying to bring everything in terms of cosine because my final answer is in terms of cosine alone. 1 minus cos square theta into 1 plus 1 minus cos square theta whole square is cos power 4 theta. Sin square theta can be written as 1 minus cos square theta within the power. 1 minus cos square theta into 2 minus cos square theta whole square is cos power 4 theta. 1 minus cos square theta plus, use a minus b whole square formula. 4 minus 4 cos square theta plus cos power 4 theta is equal to cos power 4 theta. Let me just multiply fully inside here. 4 minus 4 cos square theta plus cos power 4 theta minus 4 cos square theta plus 4 cos power 4 theta minus cos power 6 theta minus cos power 4 theta is 0. 1 cos power 4 theta gets cancelled, plus minus gets cancelled. 4 minus cos power 6 theta plus 4 cos power 4 theta minus 8 cos square theta. Minus 4 is minus 8 square, 8 square theta is 0. Bring every negative to the other side. Now for cos power 6 theta minus 4 cos power 4 theta plus 8 cos square theta is equal to 4 is the result to be proved. That is the result to be proved. That's what the result to be proved. That's what the result to be proved. It's not at all a difficult task. Okay. Before going into the next problem, I'll just explain a simple concept which is known as principle of mathematical induction. Principle of mathematical induction. Just see here. It's not at all a difficult task. If a mathematical proposition P of n, if it is in terms of n, therefore I call it as P of n. A mathematical proposition P of n is given. To prove that it is true for every natural number n, what I will do is, I will prove P of 1 is true. And I will prove P of k plus n is true whenever P of k is true. P of k is true for some k element of natural number, set of natural number. See here, whenever it's true for k, it's true for the next natural number k plus 1. Already you might have proved it is true for the first natural number 1, P of 1 is true, therefore because of this result 1 plus 1 it is true for 2. Again because of the result it is true for 2 plus 1 3 and so on. Therefore it is true for every natural number n. I repeat, this rule is called principle of mathematical induction. We call it as, a short form is PMI. We also call it as PMI, principle of mathematical induction. Just I repeat the whole process. If you are given a mathematical proposition P of n, in terms of n it is given. To prove it is true for every natural number n, for every, the symbol is called for every, this is called for every. We prove initially P of 1 is true. It is true for the first natural number. Whenever P of k is true, I will prove it is true for k plus 1. P of k plus 1 is also true for some natural number k, for some natural number k. Therefore, whenever it's true for k, it is true for k plus 1 also. Therefore, already it is proved it is true for 1. Therefore, it's true for 1 plus 1, 2. It's true for 2 also. It is true for 2 plus 1, 3 also, and so on. Therefore, it's very simple to follow. It's not at all difficult to follow. It's a very simple result. Okay. This rule is called principle of mathematical induction. Principle of mathematical induction. Let me just take a simple example. Okay. Let me just take a simple example. It's not difficult one. Just see here. Prove by induction. Induction, PMI, principle of mathematical induction. Everything is the same. Prove by induction that 9 power n plus 1 minus 8n minus 9 is divisible by 64 for every n element of n, for every natural number n, for every positive integer, for every natural number, anything is the same. Divisible by 64, multiple of 64, anyway you can interpret. Answer, let 9 power n plus 1 minus 8n minus 9, okay, 9 power n plus 1 minus 8n minus 9 is divisible by 64. Be P of n. I assume it to be P of n. 9 power n plus 1 minus 8n minus 9 is divisible by 64. Be P of n. Okay, let us consider P of 1. For 9 square minus 8 minus 9, which is 81 minus 17, 64, which is divisible by 64. Therefore, P of 1 is true. I am able to prove the result is true for the first natural number 1. Let P of k be true for some k element of n. What is the implication of this? I mean to say 9 power k plus 1 minus 8k minus 9 is divisible by 64, which implies 9 power k plus 1 minus 8k minus 9 is some 64 L element of n. That is the meaning. Let me call it as 2. Now I need to prove the result is true for k plus 1. Therefore, 9 power k plus 2 minus 8 into k plus 1 minus 9. I had to replace n by k plus 1. That's the meaning. Can be written as 9 power k plus 1 into 9 minus 8k minus 8 minus 9, which is equal to, this can be replaced by 64L plus 8k plus 9 times 9 minus 8k minus 17, which is equal to 64 into 9l plus 72k minus 8k, I can group, plus 81 minus 17. This will be 64 into 9l plus 64k plus 64. I'll be able to take 64 as common. 9l plus k plus 1, which is a multiple of 64. Multiple of 64 divisible by 64. Either way you can write. Therefore, P of k plus 1 is true. P of k plus 1 is true whenever P of k is true. P of k is true for some k element of n. I call it as 3. Now let me give the conclusion here. 1 and 3 will imply you P of n is true for every n element of n. This rule is called PMI, by principle of mathematical induction, by PMI. Let me explain the whole lot. Without for every n element of n, I assume the whole lot to be P of n. If I write for every n element of n, I am assuming the result itself. That's the meaning. Without for every n element of n, I assume 9 per n plus 1 8n minus 9 divisible by 64 be P of n. Let us consider P of 1. 9 square minus 8 minus 9 minus 8 minus 9 81 minus 17 64 is divisible by 64. P of 1 is true. Assume P of k is true for some k element of n. If 9 per k plus 1 8k minus 9 is divisible by 64 can be written as some 64l. If 9 per k plus 2 minus 8 into k plus 1 minus 9, what happens to that? We are trying. 9 per k plus 1 into 9 minus 8k minus 8 minus 9. This is replaced by 64l plus 8k plus 9 from 2. You can write the reason from 2 here. Now 4 here multiplying 9 inside, 64 into 9l plus 72k minus 8k plus 81 minus 17. Here it is 64k plus 64. Take 64 as common. 9l plus k plus 1. It's a multiple of 64. Therefore it is divisible by 64. Therefore I assumed P of k is true for some k element of n. I proved it is true for the next natural number k plus 1. Take down and write. Sorry, P of k plus 1 is true whenever P of k is true for some k element of n. Name this as 3. 1 tells you P of 1 is true. 3 tells you it's true for k plus 1 whenever it is true for k. 1 and 3 will tell you it's true for every natural number n by PMI. Every natural number n by PMI means principle of mathematical induction. Rest we'll discuss in the next video. Thank you students for patient watching. Every other problem will be definitely very useful to you. You need to grasp the things whatever is being done by me here, and you need to apply your mind at the time of doing your examinations. Thank you students for patient watching.